Hi everyone. So today we'll be trying to make some contributions to SimpleWeightedGraph, which is a package of a GeoGraph graph organization handling, well, as it says, simple weighted graphs. So a weighted graph is basically a graph where edges, which are the links between some nodes of a graph, can have a weight, which is a real number. And so a simple weighted graph makes the assumption that if your weight is 0, it means you have no edge. So that's basically it. So you have plenty of applications for these kind of things, logistic networks and other things. So we'll be doing some very minor contribution. We don't want it too long stream, so I just clone the repo. Let's start here. We'll be starting from scratch. And first thing we're gonna do is test that the package is working fine as it is now. Zooming a bit here. Okay, it's resolving, getting all the dependencies. Ignore warnings. Okay, so it's using LightGraphs 1.3, which is the last version. This is fine. Oh, okay, ignore warnings. Fine. Maybe at some point we should just suppress the warnings in the tests. Okay, this is not something to suppress. So we have some. You have some minor warnings here, which is these here are deprecated, and we're supposed to use something else. So we're supposed to use this instead of that. That should be fairly easy. So we could just replace everything. We could do that first. That could be one contribution, maybe one PR. That one I'm not gonna touch because this is tricky. So compression format for graphs, I'm not that familiar with it. So we're just not gonna focus on this, and then we're gonna see what's next. So first thing, let's open Atom here. Activate the repo. So we're in the good thing. Project Toml. Okay, project has already changed. That's interesting. Okay, it's reputting the dependencies in alphabetical order. That's okay. That's fine. All right, so we have these dependencies, and we have some simple tests throwing warnings. So we'll start with complete graphs. Okay, that's interesting. One of the complete graph syntax has been changed, updated to the snake case one, but not all of them. So not this one. So that's already better. Complete graph. Do you have some? Nope, no more complete graph. And cycle graph. Same thing. Alright. Cycle graph, and we're replacing this with cycle underscore graph. Replace all, yes, please. Alright, and then path graph. And then replace this with path graph. Oops. Alright, yes. Alright, so the test should now be fine. So we didn't change anything since these all are exported and these are already defined in the 1.3 version. Thing is, this was not defined before 1.3, I think. So what we'll do is in the project Toml compat, yes. Oh, this is already there. Okay, perfect. So LightGraph has to be at least 1.3. That's perfect. Okay. Okay, so we only have warnings related to these, which should be ignored, and then the compressed format, which we are not gonna touch. So, oops, I'm still on master here. We have two modifications. I just created a new branch from there. Deprecations, special graph. Fix. Fix special graph deprecations. All right. Remote add fork. Do I have something? It's not that. It's SimpleWeightedGraphs.jl. I should have something like this. Push fork. And yes, perfect. So this is gonna be a first PR on the project. Yeah, I won't add any documentation here because this is really fairly standard. And from there, we're gonna create a new branch. Let's check the project first. Micro. Yeah, one thing I saw was simple weighted graph. Yes. Here we are, I think, the constructor. So you have a constructor. He is taking a sparse matrix. So this is fine. And only a sparse matrix. Abstract matrix, okay. Okay, that can be fairly dangerous because we're transforming any matrix into a sparse one, which can be very expensive in some cases. Okay. So this is basically copying it, okay. Maybe we could do a bit of formatting here, where T, we don't need that big, TU, and turn. Okay, so it's strictly the same thing, but just on 3 lines, so it's not the 1-line function syntax with the equal. It's function da da da, and then the function body here. Okay. All right, here. Taking, we should not take simple graphs and simple digraphs. What we should take is, so we have different things. What we should take here is basically an abstract graph, because the operations we need on the graph are just exactly these. So these should be fine. Yeah, because let's put some space there. This is just x, which is an integer broadcasted on the adjacency matrix of a graph, and the adjacency matrix of a graph is always defined. So we don't have we don't need to have the concrete type simple graph here. We can just use the abstract light graphs dot abstract graph. Okay, so I guess that's one thing we can remove. Simple weighted graph, which is going to take abstract graph of T, type U, okay, where T, same thing as before, we're just saving one where clause, function Okay. So we should always have, I think, a conversion here. That sounds fine. Otherwise, so this is taking this here is currently taking should take oriented graph or digraph following the light graph syntax, and should take non-oriented graph. And something, we're going to put that on several lines where T U viewing is equal alright, so it's better. For now, okay, so well, we'll see about these other ones later. Maybe let's take care of this and that first. Okay. Yeah, we should maybe not have removed that too soon. So that was a simple dgraph. I'll just put it back there for now. Okay. So what we want instead is a constructor simple weighted graph, which takes an abstract graph of type T and a type U. So T is here an integer, the integer type of a graph, and U, yes, please. And then we will dispatch on whether the graph is oriented or not. So the function for this is light graph dot is directed G. Okay. So if light graph is directed, then we need to convert the graph somehow to its equivalent, to its undirected equivalent. Maybe we should have an abstract function for this. I don't know. And else, so else this means the graph is not directed, and then we can just use the adjacency matrix like this. Yeah, else that's gonna be a simple case, let's say. So if light graphs, if G is directed, then we need this yeah, we need this conversion for now. I think that's the best we can do. It's a bit sad, I don't like it that much, but we can maybe compute the adjacency matrix with is directed. Yeah, that's here. Okay. Edge matrix equals, if the graph is directed, then this, else that, and then return simple weighted graph of this adjacency matrix. Yeah, we should still, I think, maybe I did to do for later. To do abstract function instead of simple graph constructor. We should not need to construct a simple graph every time we want to do this operation. Okay, written simple weighted graph of this. Sure. Then this means we don't need this anymore. This is redundant. This is also redundant. Yes. Okay, and then the default weight. We need the same. Maybe this this one here should be refactored as a special case of this one, but that's maybe for later. For now, I think we didn't break any tests because we just made the constructor more general. So we're gonna see that if that worked or not. Nope, no, we did something. Okay. Adjacency distance matrix must be symmetric. Yes, okay. Interesting. What did we do wrong? Oops, sorry. If a graph is directed, we're supposed to have a non-symmetric adjacency matrix. In that case, we compute the adjacency matrix of a simple graph. Otherwise, we compute the adjacency matrix of yeah, that should. Oh no, we are. Yeah, we are not using. Okay, that's fairly simple. We were just not using our adjacency matrix here. Too bad. Okay. Alright, is this better? Okay, we don't get the same error at least. Yeah, this seems good. Alright, we didn't create any new warning, that's a good point, and we don't have any other problems, so this is really fine here. Okay, so we can, I guess, do the same for this part here, which is doing the same thing with a default weight. So the default weight is a real number, and or TU, okay, and this is broadcasting the weight on the adjacency matrix. Okay. So it's really the same. It's really exactly the same thing as above, except that we convert the matrix to a matrix of U. Yeah, this is even done here and there. But okay, I guess for the API's sake this is fine to have it, but do we need two separate functions? I don't know. I don't think so. Okay, well, let's just do it first. So this is taking now like graph abstract graph XU where TU, okay, and then return. So if is directed, is this the same thing roughly? Yeah, I think it is. So instead of this here, it's matrix. Okay. So broadcast it x times adjacency matrix. I don't think we have broken, anything. So yeah, sadly the to-do is exactly the same place here. Okay. This is fine, same warning as before. It looks pretty good. Yeah, we have still the same warning, but nothing more. So that's a good thing. So we've reduced the code from the multiple constructors by just checking is my graph directed or not. So this is just a zero cost compile time eliminated check, because is directed depends only on the type of G. And so depending, so the branch, the useless branch is going to be eliminated by the compiler, and the only thing we keep is the good thing. So if it's got directed this, otherwise this, and then we just simplify to two functions. Okay. Then what is this one? Simple dgraph and default weight. Is this even called? No, I don't think so. Wait, what is it? We I thought we deleted two methods for. Oh no, we just deleted one of the methods, so the one with simple graph. So it's basically now the same thing for simple graph and simple dgraph. So this one we should not use anymore. And then this one, we prefer explicit returns. Type simple weighted graph. Okay, G simple graph. Oops, no. Yeah, same thing here on formatting. So this is the constructor, tu, simple graph is returning. Okay, is this really? I'm not sure how different this is from the one above. I don't think it is any difference. So for now, I guess we can just comment this and try to test it. Oh no, okay, I get it now. Yeah, just when I run the test. This is a constructor with the two specifiers here, the two type parameters t and u, while this doesn't have anything. So I think we just deleted, yes, we did delete one method that was actually used. Okay, fair point. Yeah, that's what tests are for. Okay, let's put this function back, and then we don't need. Yeah, we don't really need this here. This should again abstract graph of t. Oh, it doesn't. Yeah, it doesn't even need that. Because we can always construct a simple graph from any abstract graph by just iterating over the edges and putting them in our simple graph. So this is a fine constructor. The thing is, now we don't know if this G is directed or not. So we're going to do exactly the same thing by computing first the adjacency matrix and then using it. So if is directed, we construct the simple graph out of this simple graph of type t with gu. Okay, so we keep the type parameter that was specified in the constructor, so here, and u. Okay, and otherwise, so if it's a simple graph, a real simple graph. Adjacency matrix of GU. Okay, this looks fine. And then edge matrix. I think we can just use edge matrix here. Nope. And yep, that should be fine. We don't need that anymore. Let's test. Don't seem to be getting any error. That's a good thing. So the reason I wanted to do this is so the GeoGraph ecosystem is working now on more graph types, and for that we don't want to have a hard-coded simple graph everywhere when we don't need it, because sometimes you are using for some things the underlying structure, the underlying data structure that is storing the graph, but most of the time you just want the abstract representation, which is being able to compute an adjacency matrix or check some edges and so on. Okay, so this first PRE is green, so that's a good point also. Okay, and the tests are passing, so that's great. Graphs with sources, destinations, and weights. I don't think we combine equals plus. Okay. Oh, I didn't know we could do that. Combine equal plus. So we're just giving it a function. Where t. I'm being picky, but I'll just reformat this here. Max, maximum. Okay. Sparse vcat. I'm not gonna touch this. Simple graph of simple weight equals simple graph of G weight. Okay. Edge type where T and U equals. Okay. Simple weighted graph. So this is from light graph here. Edges. Simple weight edges. Zip find and Z tree. Okay, I'm not touching this either. This should be documented probably. How is this working? Find and Z is returning. Let's check it. It's in sparse arrays, and this is returning IJV, INJ are the row and column indices. V are the vector of values. Okay, so this is returning I, J, and V. Okay. And so zipping it is so this is a tuple of vectors, and yes, it's a tuple of vectors, and so zip of this. Yeah, we can just run an example here. Find NZ, find N, find D and Z. Okay, of A, this returning a tuple of vectors, and then if we zip this, this is going to return a vector, or if we collect it, a vector of tuples. Yes, no, a vector of tuples of vectors. Okay, because this is 1, 1, 3. Huh. How does zip work? Again, when you have more than two things. Multiple data readers at the same time until any of them is exhausted. What? Okay. Okay, yes, I see. So we have these three are considered as iterators. yes, so I think we have to do fine like this. Okay, yeah, that's what I wanted. So because otherwise, so without this was considering the tuple as the iterator, while here this is considering each of the ijv as the iterators that we're consuming. So this is returning row, column value, and so on, I think. Yes, row, column, yeah, that's the values here. Okay. This is a very compact thing here, but yeah, sure. Okay, yeah, that makes sense because the graph is supposed to be directed. At the edge will override weights. Sure. One thing we might want to do is being able to set the weights of a simple weighted graph, because I don't think there's nothing for a moment here. So we might want to add a set index syntax, so it will be like g equals simple weighted graph with some data, and then we will add something like g of 2 for weight equals 3.5. Yes, something like that. Yeah, that sounds nice. And then we can extend this to metagraph, which is the other graph type with roughly similar features to this one. Okay. We might want to commit first. Bit too big. Simplify constructors. Use abstract graphs. Okay. One thing we might want to do is use some other graphs in the tests to increase coverage, to be sure that we're now using abstract graph, but it actually does work for graphs that are not simple graph. We don't have any more of the underlying assumptions of the data structure of simple graphs. Okay. Do we still have simple graphs somewhere? Except in constructors. Yeah, the thing we should not have actually is simple dgraph. Okay, we don't have it anymore. Good. Okay. I guess we can do the same for simple weighted dgraph now. Yeah, maybe it should be parameterized somewhere. Should this be, whatever. Permute equals true. This should be documented. Permute equals permute, okay. And then permute is a bit of formatting. Permute new permute dims, otherwise new. What is permuting doing again? Permute dims. Reshape vector v into a 1 length v row matrix. So that's for a vector. Okay. So what we're permuting now is a matrix. Permuting of a matrix, yes. Permutes the dimensions of a matrix M by flipping the elements across the diagonal. Differs from transpose that the operation is not recursive. Okay, but sure, it's not recursive, but is it actually the same? If I have, and my A, what does it look like as a matrix? Okay, and then permute dims of A. Okay, that's a transpose, if I'm not mistaken. Yeah. Okay. So if, except for technicality of not recursing, from what I understand, this is more or less a transpose. Okay. Permute. Okay, maybe we should just leave this as is here. Okay, this is taking a sparse matrix, that's fine. We are completely okay with that. Yeah, that's okay. We don't want this taking assumptions on the graph type when we actually don't need assumptions. Abstract simple graph, do we need that? No, we don't. I think we could just use abstract graph here, because we are not using any specific assumptions of abstract simple graph or of simple graph. Sure. Are you real? Okay. T type G. Okay. Wait, but this is parameterized here, T by T. So we don't need that. Okay. So this is of abstract graph. And this will be abstract graph with default weight. Oops, tiny mistake here. It's just that. Where yeah, U T. Okay, maybe add some space here. That should be good. Okay. Sources, destinations. Okay. That sounds simple D graph. Out of this is just simple D graphs up weights. Okay, so it's taking a matrix and checking if it's 0 or non-zero. Why not? Edge type. Okay. This is not moving. This is using transpose. Or sorry, adjoined. I think. Yes. Oh, no. So this is special syntax. How do you? Oh no, this is parsing this as a special. We have a. And this is, yeah, it's an adjoin, not a transpose. Slightly different. We don't need that. Yeah, that's a bit ugly, but fine. Okay, sure. For now, let's first check that we haven't broken anything. Just see, that could be a nice name, but let's just first check that we haven't broken anything, and then we'll see how do we improve that. It's mostly been logistics for now, so I hope to get to the interesting parts, which would be mostly adding a method with adding a method for setting weights, as we mentioned. Do we simple? Okay, sure. I am. Yeah, cool. We didn't break anything, so I guess we can now commit. Let's just check. Yeah. Simplify the digraph constructor. Okay. Oh, we are still on deprecation. Didn't we create a new branch? I think I wanted to, and I forgot. Perfect. Yeah. Oh, I hope it's not gonna be too messy. Git branch. Abstract constructor. Okay. So we are good here. I'm not sure this is this new syntax is going to be very bringing a lot of enthusiasm from the maintainers. We'll see, because it's a bit weird to have g of 1 to weight if you don't have anything other than weight here. This is just a convenient thing for the syntax, but if you have something like this, what are you supposed to return? I guess not an error. Nothing. Yeah, nothing could be a possibility. Yeah, it means that's not great, because this means that g. I just realized if we have g1 to weight like this, this cannot be type stable because weight here is a value. What you could have is just force people to use weight like that, to use a val. This can be okay. All right. Yeah. Well, let's do this. I guess we can start with simple weighted graph first. So after the constructors, because we want to leave this first, I want to leave the key API there. Weights. Okay, so after the key API, let's say we're gonna add this here. So first get index of g, which will be a simple weighted graph at index I, j, integer, so any integer will do. So g at I, j, and val s or s. So this is going to be for any symbol, and this will return nothing. Now that's the boring case. If we have now a val of weight, we're just going to ensure that this is valid. Okay, yes, it looks right. Okay, yeah, that's correct syntax. So if we have a val weight, then we're going to dispatch with getting the value of a weight at ij. And for that, we could we could also dispatch with an edge. That could be nice. So okay, I think we're gonna need some type parameters here. Yes. So if has edge ij, so this is gonna do or return 0 of we could either return 0 or out of bound. I think 0 is sane. Yeah, people should expect 0 from that. Return so 0 of type in which order it is, T and U, or S, or T, U, S, and it's returning 0 of T, which is T the integer or a float? We should maybe name them better. T is the integer and we want the float, so we want U instead. So if we don't have an edge, ij return 0, otherwise we know we have it, and we can also use this inbound magic inbound return inbound g weights, and not that, but of ij. Okay, and g weights ij is supposed to return also a u, so we're fine on the type stability here. Okay, so we wanted to have the same function for edges. Instead of ij, this is here e, which would be simple weighted graph. Yes, this type, simple weighted graph edge. Weight, okay, has edge g e or return 0 u, return inbound, and then it's src, the source of e and the destination of e. Okay, this should be fine. Okay, yep. Maybe I'm not sure we should reach it. Maybe we should just let the weights throw an error if we don't have the edge. It's an interesting design decision. Do you want an error when you have a graph with 3 vertices and you're trying to get the weight at 4 or 7, or do you want? Yeah, I think you want an error in that case. So this means we're just gonna leave the error. So no inbound. Inbound is removing the error and can give some very wrong false positive if you don't have a guarantee. Oops, shadow weights. Yes. Okay. We could even ignore this here and just leave the error. Yeah, we'll leave a method error, so people get a method error. We don't have anything with val of anything else. Yeah. Okay, let us test this first. So we added some features, but we did not test them yet. So we should not get any error, except if we have some wrong syntax somehow. In the meantime, let's start this. Okay, so where should we put this test? Simple weighted graph, I guess. Yes, we have just one big test. Okay, maybe we do a nested one with test set. Getting weights. So we need to create a graph first. Simple weighted edge. Okay. We're just testing simple weighted edge and not simple weighted graph here. That's a bit of a bother. Do we have some data to work on? It's just basically testing constructors. It's not great. Alright, we just create our graph from scratch. Simple weighted graph. So this is going to create a graph with the default types, I guess float 64 and int, and with 0 vertices, and then yeah, maybe we'll add an initial number of vertices, so 3. Okay. So if we don't have an edge, this should be 0. So test. I don't have a prox here on this. This is a bit prettier than a text version. GF1 1 1 2. Wait. Prox 0 1 3. And then test throws. This will be, what do we get if we so A is still our matrix here. What do we get if we have 7 7? This should be out of bound error, but bounds error. Okay, bounds error. So the computing, let's say 3 4. Okay, so let's test that. Oh, okay, method error. Now we're getting interesting. Let's zoom out a bit because we have many errors here. Method error is ambiguous. Oh, so we have an ambiguous method. That's very interesting. Val s. Can we not dispatch on this? Yeah, the first one sounds more specific. Oh, and I also thought we removed I thought we removed the other one. No, we didn't. So how is this ambiguous? This should be equally specific, except here the value is given. Could that be this here? I'm not sure. It should not be the case, but where S? Okay, right, so T U. What does this give now? Okay, this looks way better. So we now have our tests, including the new ones, which are here, the 3 new tests. Yeah, and then test. Let's say we have a typo here, so wait, like this. Let's put a correct one, otherwise this could be confusing. This should be nothing. Okay. I'm still not sold on using nothing instead of a simple method error. Oops, no, yes, wrong syntax. We don't have a bound error here. And yeah, this should now be fine. Well, that's taking a bit long, more than usual. Okay, no, we have the same warnings as before, and we have our test. Okay, good. Well, I feel we can do now the same for the neighboring type micro simple weighted D graph. Yeah, let's copy the implementation from there, because we're fundamentally doing the same thing. I'm not sold that we need to on the fact that we need 2 implementations for weighted graphs here. I think one would do with a type parameter on it, but well, that's another PR, another time. So we are now working on simple weighted D graph, still with the same type parameters. Simple weighted graph edge, I hope, has the same type. Yes, simple weighted graph edge, perfect. And this is exactly the same logic. That's why we should have just, maybe we should use a union. Yeah. Yeah, maybe we should use a union, but well, same thing, that's for another time. Or maybe, yeah, maybe once these tests pass, we should use a union. Okay. What does this give? So again, a note for those who are not familiar. Base get index is some convenient syntax for what we did in the test, which is calling like this with the square brackets. So this is get index of G with these values as next parameters. Okay, perfect. This is all passing. And we're going to do the same thing. Test and simple weighted D graph. And maybe we should also use test inferred. Oh, and also we just check that everything is 0 at the beginning. Maybe we should also add some edge at some point and verify that it's still valid afterwards. Okay, so the beautiful thing is we don't need anything more here. We can test that. At the same time, we're gonna do some more sophisticated tests in the simple weighted graph case, which is basically, so this is just a basic setup of our functions that we're testing, and then okay, no error, no. So add edge of G 1 to 5.0, okay. then test that this is now approximately equal to 5. Okay, tests are passing. Yeah, maybe we should check that. So this is supposed to be symmetric. No, wait. We are in weighted graph. Why do we have digraph here? Wait, I'm confused. Yeah, weighing graph. We're not supposed to have digraphs all around. Yes. Okay, so this is weighted graph. So this is valid here, while this will not be valid in the digraph case, which we'll do just now. Simple weighted. Wait. We do have. Weighted edge. Oh wait, what did I do? Oh no, we don't have a simple weighted digraph. Where did I write this to? Oh, simple weighted edge. We don't want that here. This is for digraph. So there's a test set syntax for G in. There's a test set syntax which uses 4 comprehensions, and I think this is the proper use case for this. Test. So you create one test set for different things. Yes, test set description depending on V, for V in. Okay. So the description is here, and it's testing for G in. Okay. Oops, nope, and that, yes. So we're creating G like this. So G is either this or that. We have the same thing here. And then if is directed of G, we test this. Otherwise, this should still be 0. Oops. Okay. Let's see if we did mistakes here. This should be fairly fine, I think. But every time I say it, we usually get mistakes. Yes, exactly. Okay, I think so. If it's directed, we're supposed to get 0, and if it's not directed, we're supposed to get 5. Thank you. And yeah, so we got two errors which were roughly the same. So this should now be fixed. And we now have more than, oh no. Do we still have an error? Did I save the file? Yes. G12 weight equals 5. Yeah, this is supposed to be the case. We did add the edge here. 1, 2. Not sure. Oh, wait. Oh no, okay. No, this is not supposed to be 0. We could use some good old-fashioned debug info, but I guess here we'll just work a bit interactively. Simple weighted graphs. Okay, let's try with variable. So G equals. Let's do simple weighted graph. I think let's check where it failed exactly. Oh, it only failed for a simple digraph. Weighted graph was fine. Simple weighted digraph with 3 vertices. Okay. So yes, we need using light graph. Oops, no. And light graph. And add edge. G1, 2, 5 to 0. Okay, so G is now 3 vertices, 1 edge. G of 1, 2. So this should error. Yes, we don't have this method. Well, wait. That's bizarre. Oh, 2, 1. Wait, this is stored in reverse mode, in reverse order, let's say. I think this is a storage thing about column major. Okay. The matrix is stored reverse because it's a column first matrix, something like that. So it's more optimized for some operations in this way. So if the test is correct, yes, did I do changes? Yes. The test is correct, the implementation is not. Simple weighted digraph. Because here, we want JI and something there. I think. Oh yeah, destination and source. I misread that. Okay, perfect. So J and I, destination source. Maybe we should, for consistency, we should maybe do the same in simple graph. So the undirected case, but I'm not sure. This is not bringing much here. Okay, in any way, our tests should now be fine. In the meantime, one thing we could do is document a bit what we've done. Simple weight up. G of E, which is a simple weighted graph. Evaluate. So that's how you call it. It's usually the first line of a docstring. Equivalent to G of src E est E. Okay, let's copy this here, and that's this case I integer J J integer, and that's return the weight. Oh, yeah, we forgot the important part. weights. Oops. Return the weight of edge ij. Okay, and our tests are passing. Okay, we have documentation, we have tests, they should all be fine. Okay, I think we can just try to get our PR through now. This might take a while, but at least we have something I think a bit consistent, and this is adding a very convenient syntax for graphs, because we didn't have any way to query the weights without getting the g.weights, which is manipulating the matrix itself. And we don't want people to use the matrix type itself and the underlying structure. They just want weights out of our graphs. So we don't want them to know that we're using a column major matrix. It should not be relevant to graph users. And get index on graph weights fork abstract constructor. Okay. So I guess I'll do the PR now, but afterwards this is gonna be it. Yeah, let's get this done. Yep, sounds alright. Yeah, maybe I should add a description. Okay,